I know because the other classes that I teach are Algebra 1 and Precalculus. That's why you hear me talk about those things a lot, okay? I know in Algebra 1 you were taught this. Here's what I also know. What year did you take Algebra 1? 8th grade. What happened in the spring of 8th grade year in Algebra 1?
COVID.
Yes. So even though you were taught this, and those of you who were here, you were in the same boat at the high school. It was just you had a different teacher, okay? You might not remember this because it might either you blocked it out or you didn't really do it, or, I mean, because everything was quote unquote optional. If you lived with a math teacher, it wasn't optional. Dang it. That's where it stinks to live with a math teacher. Do you remember that? Negative b over 2a. Okay. So when something's in standard form, the way that we find a vertex is we take the opposite of the b coordinate and we divide by 2 over a. I could derive it for you, but it would take a really long time. You just gotta trust me, okay? To find the y coordinate, there's 2 ways you could do that. You can use this formula. See, it says c minus ah squared. That's this c, and that's that a, and that's that h I already found. But I have found that algebra students in the past think it's easier if you find k by doing f of h, and that means take your function and plug in what you found for h. So I'm going to say plug it in. So I think that's the way I'm going to show you. Even though our textbook will tell you this formula, they both work. I'll show you that they both work, then I'll give you choices. We like to have choices, right? Vertex form. This I know you studied last year. Vertex form you can think of as a transformation from the parent function. If we moved something minus h, do you remember how that moved a parabola? Right or left? Right, h, and if we added something on the back, didn't that just move it up? So basically you're taking your parabola and you're moving it, okay? We call it vertex form because that little low point of the parabola is called the vertex. And so HK is not only the transformation, but it is also the new vertex of your parabola. Okay, there are multiple ways to get from standard form to vertex form. One way is figure these out and literally rewrite it. And notice this A right here. That A is the same A there. There's no figuring out. Whatever this A is, that translates to down here. Another method is completing the square. Who remembers a little earlier in the year where I showed that? It was just really informal. I showed it on the board. And I told you I don't usually use completing the square to solve equations, but I do use it to do this. So I am going to show it to you again. Quite frankly, as long as you can do this algebraically, and what I mean is not using your graphing calculator and using the minimum key, as long as you have an algebraic way to do it, if it's this or if it's completing the square, I'm good with that. Okay, let's draw a little picture of a parabola. So just for the heck of it, I'll make it open down. This is called the vertex. What I'm saying is, for reference, when I refer to HK, I'm referring to the vertex point. So it's either the high point or low point of the parabola. A tells you basically how tall the parabola is 1 unit away. And so in this case, I know what about A, if this parabola was opening down. I'll write this. If A is positive, the parabola opens up. If the leading coefficient is negative, it opens down. Okay. So, let's just sketch some pictures. And then I'm going to show you, I think I'll show you a completing the square one. So from x squared, let's think transformations. This is x minus 3 and x plus 2. How did this parabola move? Somebody tell me. So for my sketch of my picture, what I would like to see is, hopefully at this point, I'm going to draw this. This is x squared. For my key points for x squared, the parent function, I'm going to say it goes through 0, 0, and let's just use the point 1, 1 and negative 1, 1. Those are really easy points on a parabola. Just make sure it's U-shaped. So for your sketch, would you just move those 3 points, 3 to the right, up 2? So now instead of your vertex being at 0, 0, it's at 3, 2. And again, I can go up 1 over 1. I know that this is a 1, that A is 1. Don't call it the slope, because technically slope is for a line only, but it's kind of like the slope. It's like the rate of change around the vertex. And then we would draw our nice smooth curve. I should have drawn this on my original. There's something called an axis. An axis is literally just a vertical line that goes through the center of the parabola. So this has coordinates 3, 2. If I asked for the axis of symmetry, it would be the line x equals 3. Okay. Let's try B. Oh, lots going on here. Negative in front. Who remembers? What transformation is that? Reflection or flipped over x axis. That's the negative part. The 2 is a vertical stretch of 2. What we're going to do in a second is we're going to stretch those over 1 up 1 points to over 1 up, or actually down 2. We're going to stretch those. Minus 1 is right 1, minus 7, down 7. Okay. So my sketch of this picture, I'm not going to redraw the parent function. I'm just looking right there. That's my x squared graph, the ones that's dashed in green. I am going to move it. I'm going to move it right 7 and or right 1 and down 7. I'm going to make it, instead of opening up, I'm going to make it open down. That's the reflection part. And I'm going to make it narrower by stretching those points 2. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go down to 9 because I need 9 points below. What's the vertex? What are the coordinates of the vertex? If it moved right 1 down 7, the coordinates of the vertex are 1, negative 7. I'm going to, from 1, negative 7, go over 1, down 2. That's a vertical stretch of 2. And I'm going to also go left 1, down 2. So my parabola would be down there. Any questions? Okay. So what if something's in vertex form? Super easy to spot out the vertex. That's the best case scenario. We don't have to do any work. Just be really careful. X is a liar. Okay? I ask for the vertex and axis of symmetry. The vertex is 1, 5. That's it. The axis of symmetry would just be the vertical line that goes through the vertex. So x equals 1. Okay, try this one. Vertex, you should have put -4, 2. Axis, x equals -4. Okay. I'm going to show you how to find the vertex using the formula -b over 2a. And then finally, I'm going to show you completing the square. 2 options. For D, let's use the formula. If it's in standard form, we're going to go up here and use this formula to find the vertex. So H equals -b over 2 times A. In this case, what's -b? Let's do this on D. Yeah, no, only because I don't want to do completing the square on D because it's a huge, big old mess. So we're going to do it on D. We're going to use completing the square on A. It's 5, so I make it the opposite. So this would be -5 over 2 times 3. So -5 over 6. Are we good so far? So if you wanted to find K, you could, I'm going to show you the 2 ways. You could either do the formula up here, C minus AH squared. That would be -4 minus 3 times -5, 6 squared. Quite frankly, I would encourage just using a calculator at this point. Or you're going to do f of -5, 6, which is you plug it in for x. I'm going to do that way. Okay. So, I'm pretty confident you guys all could square -5, 6 and find 25, 36 and find a common denominator and all that good stuff. I don't want us to get bogged down with that at this point. So I would just like you to plug it in your calculator and use the parentheses option. Okay, so there's -3 times -5, 6 squared, plus 5 times -5, 6, minus 4. If you wanted to, you could change that. Do you guys know how to use the math fraction option? Wow. Oh, you don't know anything about these graphing calculators. This is fun. If you hit the math key, see that? If you want to convert something to a fraction, isn't that nice? Oh, nice. Or leave it as -6.083. I don't care. It's -73/12. So -5/6 and -73/12. Or -5/6 and -6.083 repeating. Do you want me to show you the math frac again? Or you got it? Can't tell if you guys are so quiet. You got it? Okay. Completing the square. Do you need to know completing the square? I think it's fun. I'm weird. We know that. Because I'm a math teacher and I heard math teachers are just all weird. So I'm not going to take offense to that. I'll embrace that weirdness. I like completing the square. I think it's fun. But you might not. This is another algebraic way to do this. So first, to complete the square, I'm just going to rewrite the problem. Notice I just put a y in there because it's not that big of a deal. And what I do is I take this thing off the back and I scoot it off to the side. So I have 2x squared plus 2x. I'm going to leave some space, minus 3. So far I haven't done anything except just kind of, yeah, put some space there. Okay. Then what I'm going to do is, do you see this? They have a common factor of 2. That's my a. I'm going to pull that out to the front. So I'm going to rewrite this as 2 parentheses. If I divided those both by 2, wouldn't I just have x squared plus x? Agreed? Leave some space here, and we still have the minus 3. Then I have to pick this guy. Ugh, anybody remember how I do that? This is a 1. I have to pick a number to put here. Okay, you go back to your b. b is 1. Take half of it. What's half of 1? 0.5. What's 0.5 squared? 0.25. You're going to add 0.25 here. Okay? I just added 0.25 times 2 to the problem. Take it off the back. Well, Ms. Comrie, you added a 0.25 here. How come you're taking off a 0.5? Because this is really 2 times 0.25. See that? And then last step, you're going to write it in factored form. This is 2 parentheses x plus 5 parentheses squared minus 3.5. What is the vertex? The vertex would be -5, comma, -3.5. That's completing the square. I'm not spending a ton of time on that, but because some of you will never use it, but some of you will. Please feel free to ask me again.